Great, thanks, Alex.
Yep.
I'm putting in the chat a link to that request for information, and then I'll also add in the chat kind of the questions that we're asking folks to answer. So yeah, I'm happy to answer any questions that I can about this, or talk more about it later too. The request for information for this round of public comments ends November 15th.
That's great. So I would like to do something on this just so we are, as a group, heard within this forum, that we have some visibility and maybe that we as a group understand this IR pick better to be able to maybe reel in more money or find out who has problems that we can solve, or potentially can help with. So we'll bring this up again. Margaret and I had some emails about it. Not sure exactly what we're going to do, but I would like to bring these questions back to our group with a clear understanding for the group of what the heck IR pick is trying to do. That's how we have to answer these questions, as I see it, is like these questions are in the context of IR pick. So I'll have to do a little more understanding of that, and then we can bring this back to the group. That's how I'm thinking about it.
Thanks, Alex. Yep, and for total transparency's sake, well, as much as I know, we're just as unsure about things as everyone else. So we are, the amount of clarity that we're able to give around what the future is for IARPIC is still kind of, we're uncertain too. But that doesn't negate any comments that we receive getting incorporated into the update of the Arctic Research Plan.
Um, okay, Jasmine and Angie are referring to the same thing here, the status of wastewater. This looks like a fascinating report. Thank you.
Yeah, I just realized
That,
Jasmine had done the same thing as me. Sorry.
well, no, this is not sorry at all. It just shows that we're on the same wavelength. It's great. Thank you.
Yeah, I thought that was great that we put that in the same time at the same time. It was great.
Yeah. Good. Thank you. Is this open source? Can I download this thing? It looks like I can. Yes.
You should be able to, yeah. I'm pretty sure.
Okay. Cool. Anybody, you know what? These are all people that we can recruit to our group, all these authors. We're going to be like the worldwide leading group, I'm telling you. From humble beginnings to prominence, we're going to be mentioned in next year's State of the Union address, I'm sure. Margaret, you're going to be up there. You're going to be in the audience. The camera's going to pan over to Margaret. Okay. Yeah, sorry, that was bizarre. So we have another participant here. Any quick update? Who is that? Jamie J? Jaime? Who is that?
Hello, do you hear me?
Yes,
oh,
we do.
Hayes. Hey.
Hi, nice to see you.
Nice to see you. Well, I can't actually see you, but nice. I'm glad you're here.
Okay, let me check. Okay, I'm here.
There you are.
Hello.
Hello.
Nice to see you again. It's a pleasure for me being here. Well, I am part of the group. You are in charge of installing and designing the anaerobic digester. And we are planning in Colombia to make some proofs in order to evaluate the behavior of the inoculum that I mean the inoculum that processes the waste in order to produce biogas. And we are focusing our methodology in order to evaluate the effect of frozen the sludge in winter and what happens if it melts. What about if it works later or not? So it is going to be the first part of our proofs of our methodology, and then we are going to evaluate the microorganisms content and the methanogenic potential of the sludge that we can prove or taste there in Alaska, in the Arctic.
Is this a lab project or bench scale, or is this a digester that's in the field, and in what kind of a climate is it?
Well, the idea is started in the laboratory, and when we have batch results, we can go there to a field and install a digester, more or less 8 cubic meters, in order to prove our results. The things that we have to look for a place that has a temperature similar or low. The minimum that we have tasted in field is 10 and 15 degrees, Celsius degrees. So we have to look for another place with a lower temperature.
Got it. Thank you. And by the way, everyone, Jaime is going to be on our call on our meeting next month, correct?
Jaime Marti, you mean?
Oh, who is this then? Jaime, what's your last name?
Jaime
It's
James.
Jaime's. He works
Jimmy
with
James, yes.
Liliana. Yeah.
Okay, I'm sorry. Don't know who's who. That's great. Thank you. Yeah, but if you have, as this work proceeds, this would be an opportunity. This group might be an opportunity to share the results. Give us a 20-minute something or other. Yeah.
Jaime, do you know about the status of the NATO work? Has Liliana been able to start signing contracts?
Yes, we have the contract has been submitted to the fiscal department. So they have checked the documents and they made some adjustments in order to proceed with the university requirements. So now we are waiting for the last document in order that the principal sign it. So we are on that. Yes, we are on that.
Waiting for the last document. That sounds very promising.
I mean, yes, the last letter that we have to sign in order to start the project.
Well, Robin has now made an appearance. He dropped his invisibility cloak, and now we can see him.
Yeah, sorry about that. That took a little while. But in any event, Alex, I will just kind of ask all the key players on the NATO program, and next time I'll take responsibility just to do 300 words or something prior to the next meeting.
Sure. I mean, let's put a pin in that. I'll put a pin in that subject, and you can give us 300 words, and then maybe at a later meeting we can hear a bit more in depth as it proceeds.
Okay.
Thank you both.
Yep, that's all. Thanks.
Hi, Annie. I just told the group earlier that I'm going to be nerding out with Walker Brown tomorrow afternoon at a small digester prototype. Don't you wish you were here in Vermont nerding out with us?
I do. I'm so glad you're keeping that alive. Wow. Please give me the report, or I'll text Walter.
Yeah, I'll definitely take pictures and stuff and give a little report. So yeah. Any update from, where'd she go? There you are. Any update from you? We're just doing quick updates and then we'll move over to Jasmine.
Cool. I guess the update is the biggest, I guess it seems like it's been in place a long time, but it's only been formally in place for the past month. But the add-on to the digester project that has to do with the rural chiller option is in place. And so that conversation has been active recently with folks designing the chiller that they'd love to run based off of biodigester gas. So they recently sent me kind of a list of questions. So it's like, these are the things we want to be thinking about this next year, how a digester would pair with our system. And so I have those questions percolating in my mind, and I think at maybe a later date, we can spend some more time on them as a group potentially. So that's probably the update on this end when it comes to things are alive. Oh, the other update is our power system went out for the first time this week. That means it's officially the shoulder season in Alaska. So we were waiting to see when does the digester start struggling in the shoulder season. We've had one of the drums that has had the one with the drum blanket has had an incredibly consistent temperature all season long. The power system has been more than enough to support that blanket running. But we had 3 cloudy, rainy, 50-degree days in a row this past weekend. And the inverter didn't have, the batteries were drained and there wasn't solar. And that was the first time that had happened. And so we saw that response in temperature. I pulled the data from the system yesterday, but I did not plot it yet. So I'll have to follow up with what the plots look like when that happens. But we did adjust the blanket temperature so it pulls a lower load and it's maintaining some life. And so we are playing around with the shoulder season, like how to operate in the shoulder season right now.
Margaret mentioned the data and offered to share it, but of course, it would be great to get it from you. I don't know how we get it or what it looks like. I'm fascinated by all this. So that's great. Interesting that you are tweaking things to use less power. It's pretty good. Interesting.
Yeah, yeah, so that's my off the cuff update.
Thank you.
But yeah, anytime we can look at more detail. I should figure out what I can obviously share draft, do not distribute, circulate type of information. But I shouldn't try to say I have big publicly available broadly speaking, the NREL publication process is very arduous at this time. Angie, do you have a question?
Yeah, I was just wondering what sort of temperature you were trying to go down to. You said you tweaked it down a little bit.
Yeah, so I'm wondering how it was just yesterday to see if the inverter would stop setting off alarms. The blanket temperature had been at 100 degrees. So like the insulated blanket that's around the drum is up that high. And we want to see if it needs to be up that high. So we dropped it down to 75 degrees Fahrenheit.
Okay. Yeah, I was just I was just it's just converting. So 75 is going to be about probably 28, something like that.
Yeah.
27. So you'll be fine at that for sure. What you might be interested in is just to see, particularly as your nights drop, because one of the things it will be to see how fast your actual temperature drops. So you're sticking in X amount of energy, and one of the great unknowns in most of this digester stuff is what your losses are, because you can do the theoretical losses with your U values on your insulation and your heat going in and your cold feed going in or whatever, but there's always the fudge factor that you need. So understanding what that fudge factor is on that particular digester configuration is quite important, because, you know, at some stage when we were talking about this with Jasmine, for example, it was, okay, well, how much energy are you putting in compared to how much energy are you getting out? Because that's always the question that people ask you. And so, you know, when you're running off grid like that, you're trying to do that balancing act of gently dropping that temperature, still maintaining activity. And I think you're good to about 25C, 26C, that sort of thing. You know, you could still do pretty well. There's lots of digester temperature curves out there anyway, but for you, you know, it's understanding what your system's losses are. So that, you know, if that's just from the sort of pain that we've had in the past, that's the sort of thing that's kind of useful to have.
Thank you.
Yeah,
Yeah.
I come from the energy world, but I also, in this case, think, oh, who cares? Like, if we can process this waste to be less pathogenic, great. Without costing a lot, great. So it's good questions, and we have to understand the thermal management because it affects how much these systems are going to cost, right?
Mhm.
Yeah. And just whether there's any benefit of just even paying to add a little bit of energy, paying, you know, going onto the grid, or paying or putting another battery on, or whatever. But
Right.
until you understand those losses, you can't make those decisions.
Right.
You're right.
Yeah. So did Margaret, do we have time for this? Okay. I might just share the plot of the temperature over the season thus far.
Jasmine, is that okay, or are you time limited?
I have to be gone by 12:50 in like 40 minutes, but I want to see this, so.
Okay. All right.
Okay. Thanks, Jasmine. We'll keep it brief because I want to hear what you've got to say over there. But this is, so this is what I'm saying. I need to update. You can see it only goes through like a month. I think the last poll was the 24th of July. So solidly still in comfortable warm weather. But even in this, so quick orientation, the top is the outside drum. Inside of the shed, there's 2 drums on this plot. The green line is the one that is the blanket heater in the shed, and then the blue is the other drum in the shed. There's some opportunistic heat. We think that resistor isn't doing much because the shed isn't well sealed though, so it is seeing a lot more fluctuation. And then the greenhouse, which really spikes with the passive solar. And so you can see that those patterns over time.
So when it says greenhouse water, that's the actual digest
So there's
vessel.
a temperature probe. So the drums aren't actually digesting. There is water in all of them with a temperature probe at the core of the water column. So when we say the drum water, it means in the middle of that water mass. And then what you see in the yellow is the ambient in each of those spaces, air temp.
Yeah, yeah.
So that, yeah, and then the purple lines highlight where there's like the biggest shock over a period. And I'll just jump to the next plot and then we can close out and you all can think about this and follow up. But we also looked at it this way to understand the band in terms of daily fluctuation. So like the band in each of these represents the daily min versus the daily max, with that average running through the middle. And so with the blanket, so the red line is really tight. You can barely even see the range fluctuate over the whole time period. The greenhouse in orange has a higher mean temperature, but it is like showing these great fluctuations. And then the comparison between the blue and the green really demonstrates that even having housing, so that shed around the drum, tightens that amount of fluctuation. It just like, it buffers it from what's going on outside. And so it does provide some of that benefit on the day-to-day. Cool. Any questions? Otherwise, I can maybe talk more about this later and give the floor to Jasmine.
I don't have any questions, but as always, I'm just excited to see see new stuff, even if it's just temp. But yeah.
Cool. Thanks. And Jasmine, I really appreciate it. I think I'll be in touch again soon, but hoping to use some of the ADM ones that you've been helping with to understand if this is what we're looking at, temperature profiles, what could it mean for our biogas?
Yeah, for
Okay.
sure. And we can also set up some individual meetings outside of that to go dig deeper into that too. Yeah, totally. It's exciting.
Okay.
Okay, let me.
Can I just make an observation? And it's something to look out for, because we've often spoken about greenhouses as being a possible envelope for an AD unit in some of these environments. One thing that you won't experience right now, but it would be really interesting to consider in winter conditions, is that greenhouses do strange things. And I used to be involved in the design and energy management of greenhouses for crops, you know, tomatoes, cucumbers, that sort of stuff. Under high radiant conditions, which is typically clear star nights in winter, stuff like that, a greenhouse actually can work in reverse. So your temperatures can actually be lower inside the greenhouse than outside. So they do have some very strange energetics under radiant night conditions. So I'm really keen to see if that ever does actually arise under anything that you're doing here. So that can be with or without kind of like an energy source, like a crop or anything else within the greenhouse. So it's just something to look out for. Don't be surprised if actually a greenhouse condition plummets more than you expect and actually reverses, and it's no longer a heat capture mechanism. It's actually a way of heat exiting the environment. So that's all. It's just to observe it rather than to, you're not seeing that in that data, but you might in very clear winter conditions. Okay.
Yeah, thanks for having me.
Yeah, that's interesting. Okay. Yeah, so because I have class, feel free to ask me any questions as I'm going through and interrupting me. I don't mind at all. I think that a few of you already kind of seen my digester presentation when we had met during the conference in Fairbanks. So I'm going to be starting just going over some of that same material. And then after that, I'll kind of walk into the anaerobic digestion model and break it down for you guys. And then I can kind of show you the model that I am currently working on right now. Okay, so we all know, we're all here to try to brainstorm together some of the issues in terms of sanitation, water sanitation, hygiene, especially for Alaska Native villages. Most of you guys are familiar with the hall systems, if the communities do have them, and most of you are already familiar with honey bucket issues as well. So I'm not going to really go too much into this just because I feel like we're all pretty good on that. So the anaerobic digester that I have is called the HomeBiogas 2. You guys can look up the company. They're called HomeBiogas. I purchased the smallest digester, which is for a household of 2 to 3 people. And it's just very simple digester. You can take your kitchen scraps or animal waste, or it can even connects to a toilet. So the one that I had purchased, I actually purchased the toilet with it. But I never was able to connect the toilet just because of the university. They had some issues with me connecting a toilet to the digester. So you put the waste into the inlet, which is where they're putting that food waste in, and then it's going to go down into the digester, the bottom part of the bag. And then after that, this top part of the bag is where the gas is going to be captured. And then the outlet is connected to a gas stove. The one that I have is connected to a gas stove that we use and is currently still being used as we speak. So the digester this digester has been up since 2023, which is great. So we're going to be going on 3 years, and it's still in really great condition. Yeah, it's really exciting. It really is. Okay, so the digester is located in Palmer, Alaska. It's located in a passive greenhouse. Basically, that just means that there is no heating, and the only heating that it gets is from the windows. It's kind of covered by the snow in the very left-handed picture. The snow is covering all the windows. So in this greenhouse, I have put up another grow tent to place the digester inside of, and inside of that grow tent is where I put the digester. And on the bottom of it, I put insulation, like an insulation pad to kind of create a barrier from the ground and the digester for, you know, the colder temperatures. So when I did start this project in 2023, it was originally in October. So it was right when the temperature started getting cold. And as you can see, the snow in this picture, it was a constant battle of snow. But it was really great because I was able to get it running and producing gas in the thick of the winter, which was the main reason for this research for me, was just to show that we can apply anaerobic digester at a very small scale, and it doesn't really have to be too complicated. And I feel like we've been really showing that so far. So we all know that it needs heating. So for the heating, starting from the very left corner, top corner, we use seedling heating mats, just what you use to grow like plants. So I have 4 of those at the bottom of the digester that lay on top of that foam pad that I put on the ground. And I kind of covered that foam pad in this like silver liner that came with it, just to maintain that heat between the seedling heat mats and the bottom of the digester. And then kind of going to the right from the top, this is when we had to fill the digester with water. So you have to fill the digester with water before, obviously you can seed it. And then after that, moving forward to the right, we had to put these sandbags in the gas tank, because when you open up the pressure valve for the gas, the sandbags will just push by gravity, push the gas out. So it doesn't really require anything super mechanical, which was great. And so the seedling heating mats weren't the only thing that have been keeping the temperature at bay. I also purchased a aquarium heating probe, a titanium aquarium heating probe. It's 1200 watts. And this is placed inside of the digester in the inlet and in the outlet. They have like temperature reading probes, but the main titanium probes are in the inlet. And so that and the seedling heating mats have been maintaining my temperature. In addition to that, we created at the bottom, in the bottom middle, we created insulation pads. And so what we got was rock wool. We put the rock wool inside of some garbage bags, and then I taped them up with duct tape. So we have about 20 of those bags. We have 4 on, the waste inlet. Then we have 5 on each side of the digester. And then we have about a couple more kind of just lingering wherever they need to be put. But then on top of that, this last picture, we're putting some moving blankets. So I purchased moving blankets. I put 6 moving blankets on top of it. And then I put this silver liner just to kind of, keep that heat in. So altogether, this is really how I kept the insulation in and kept the heat in for my digester. Okay, so this is a video. I'm just gonna play it over and over again and kind of talk about what we went and did. So I partnered with Alaska TLC Kennels, that's located in Palmer. And what I had done is I asked them to basically collect the dog poop from the kennels, put them in these buckets, and then I would collect them and I would bring the dog poop to my digester and we would start mixing. So 15 gallons of dog poop came from the kennel. This is to seed the anaerobic digester. And then 5 gallons of dog poop came from my house because I had 3 dogs at the time. So altogether, 20 gallons of dog poop to seed the anaerobic digester. And so this is like a 1-to-1. So we had to do 20 gallons of dog poop and then 20 gallons of water. And as you can see, I took a paint mixture with a drill and I mixed up the poop and I made a slurry. And after that, I had to strain all of the rocks and all of the grass out, which was really a really good experience. Just to get all those impurities out, because within the system, you don't really want your rocks, you don't want sediment collecting in at the bottom, because then you'll end up having to flush out the entire system. So after that, for about 3 weeks, you have to wait 3 weeks, right? You have to get the microbes nice and happy and seeded. Then you can move from a 1-to-1 ratio to a 1-to-2 ratio. So you can feed the digester after you know that you've gotten biogas. 4 gallons of waste. So I did 4 gallons of dog waste every single day. And so 4 gallons of dog waste, 8 gallons of water. And so with this system, what goes in comes out. So so whatever you're going to put in, you're going to get your liquid digestate that comes out. All right, so this is my temperature data of the digester. I don't have any data as of like since I've been here pursuing my PhD, but this is some of the very first data and very vital. So from October 22 to probably December 22, this is when I was going out to Palmer every single day, and I was taking readings in the morning and I was taking readings at night just to confirm that, you know, we were maintaining temperature. So what you guys should really pay attention to is the tank probe, and this is that yellow line. With all of the insulation, I was able to maintain my temperature with just those, with the seedling mats and the fish aquarium heating thing, between 95 and 85, which was really, really great out through the entire winter. And then the other thing to pay attention to would just be the orange line, which is the greenhouse temp. And so I took the outside temperature, the greenhouse temperature, the wall temp, the inside of the digester, and then I also had a temperature reading of the ground. And so over time, I stopped taking less and less temperature data just because once it was working, once I knew it was working, I was confident. And then moving into the summer times, I actually take a lot of all of that insulation off. I take all the insulation pads off. I take all those blankets off, and I actually take some of the seedling heating mats that I put on the sides. I take those off as well. And throughout the summer, I just went back in August. They have been able to maintain 90 in just with the greenhouse temperature, which is really great. Yeah, that's really great. Really exciting stuff when I go back there. So starting from the left-hand side, this first picture is the very first time that we confirmed that we were getting gas burning. So after those first 3 weeks, that's just me confirming that it's going connected to my gas stove. And then in this next one with the kettle, we're just boiling water and then drinking something off of it. I think for this, we were just confirming that we can burn for 15 minutes. And then we went to 2 hours where I burnt the entire gas out. Yeah. Yeah. Yeah, we burned for 2 hours and I burned all the gas out. This is bringing up memories. That's really exciting. And let me see. Yeah, this video right here is me eating some eggs. I'll show you guys this video. I am a firm believer that we're going to be telling people to use anaerobic digestion and that they can cook off of the gas, that we should also be doing some of these things and showing that, you know, we're doing what we are preaching.
I'm not getting any sound, but it's a great video.
Yeah. Yeah, people like that video a lot. So this was me back in August, just recently. The digester is in great shape, being taken care of really well. They actually put a composter inside of it, which is at the bottom of the picture. So as of right now, this is just being maintained by Alaska Pacific University at the Kellogg farm. And all summer long, they've been taking students out there, K through 12, and they bring them to the digester, and they have actually this little stationary area where they bring the kids in to make hot cocoa and make tea, and they all get to just like see this process of putting waste into the digester and then getting hot chocolate afterwards, which is awesome in the direction that I was wanting to get, just to get more people involved in what anaerobic digestion is. So this is the end of like giving you an overview of my home biogas system. Moving forward, we're going to keep, like, since I have received funding for my PhD, we're going to keep this going in the collaboration between APU and I, in terms of just like getting more kids involved in anaerobic digestion and letting them see the process. Before I keep going, do any of you guys have questions?
Just to confirm, Jasmine, you said when you started feeding, you were feeding every day, 4 gallons of dog waste. Yeah.
Yeah, 4 gallons. So 1 to 2
4 to 8.
Yeah, 4 to 8. Yep, every day. And
so,
go ahead.
Were you also pulling off the digestate every day.
I was.
Okay.
And that's when I was collecting a lot of digestate, yeah. And
And what
so
was that being used for?
I wasn't allowed to use it, so what I would do is I would pour it out of my lawn.
Okay.
I think that it's helped out, but I mean, I don't really have any scientific evidence to really back that up.
Did you have anything done on analyzing the digestate?
I didn't have any. I didn't have any resources. I don't have the resources that I have now, and so
Yeah.
that's kind of. I'm hoping to move toward that direction now that I'm in this position for sure.
I can't remember what because I did start on trying. We were involved in a project. I'll drop a thing in the chat, but about 7 years ago on dog do, and we were trying to get the digestate analyzed. And in the UK, we were going to need like a category 1 nuclear lab to be able to digest it or to be able to analyze it because of the potential for oocysts from some of the potential pathogens. But there was just like no data out there, but I just couldn't find a lab. So if you do, I'd be really interested to hear about it. I know it's kind of an aside to humanure, but I'd be really interested.
No, I would be interested too. It actually bring up a great idea. I'll ask my PI, which probably has some really great resources.
Brilliant.
So I have a couple questions. One is, you say you're feeding feeding so and so many gallons of dog waste per day. Is that solids or is that diluted?
No, I have to make a slurry. Like you have to make a slurry in order to be put in. That's only for the animal waste, but for food waste, you could put it directly in there. So they've transitioned. Unfortunately, we've made this transition from dog poop to food waste, and they put it right in there.
And so how do you manage? So I'm looking at this from the perspective of this project I mentioned in New Hampshire, where you have sheep manure, and sheep manure is similarly, a high solids. Unlike, for example, milking cow manure, which is, a 10% solids slurry. So how do you manage the solids, I guess, that this thing isn't going to get filled up? Because you're saying you don't have to slurry the food waste, and yet there must be recalcitrant parts of the food waste that form solids, whereas you maybe don't have those kinds of recalcitrant portions with dog waste as much. I don't know, I'm just thinking like solids management. How does this thing ever get whatever you can tell me.
Yeah, no, you're not. You bring up a great point. And so like with the HomeBiogas system, there are certain food waste that they advise you to put in and to not put in, just to kind of manage what you're saying, the solids that do come with food waste. So there are some things, they're like rules that you should be aware of, because if too much accumulates within this HomeBiogas system, you will have to flush it out. It's just a plug and flow system. So it would be kind of a hassle, but you would just have to take all the liquid out and then fill it back up. But with these systems, based off of like the Facebook page that I'm a part of, when people do that, they run into a lot of issues with tearing the bag. So with this system specifically, they really advise, like, once you have it set up, don't take it down unless you have to.
And at some point they anticipate, yes, the thing will fill up to some degree with solids, and you'll have to, you'll lose your retention time and all that. Yeah,
but I think overall though, I think as long as you're like really paying attention to what you're putting in, it can last like a really long time. The lifespan on like this one here is 15 years. And so it's been running for 3 years. And at the beginning I was putting a lot of manure, like a lot of dog poop in it. And I do know that there is some sediment on the like in there, but then I just made a point to really strain it even more. So I had to strain all of the slurries. I would strain them through just a regular kitchen strain, and then I would even get a thinner one, and then I would strain it through that as well. Yeah.
Cool.
Bringing back memories. Yeah. Any other questions?
Yeah. Oh, the heating stuff. You mentioned 1200 watt aquarium heater, and then those plant seedling heaters. What's the capacity? Like, how many kilowatt are you looking at altogether, and are you drawing on it? Do you have any idea, like, whether this thing is costing anything in electricity?
Yeah, so that is one of the things that I have not really been able to capture, but like when I purchased the heating systems, I made a point that they like weren't using a lot of electricity, and the seedling heating mats and the aquarium probe, once they reach that temperature that they're set to, they turn off. So they meet that temperature quite a bit, and so most of the time they're actually just off. But yeah, I did do the math, and I did it way back when, and I could probably find those numbers for you and get them for you, but it wasn't that much.
Good.
If anything, less than $100 to keep this going per month, especially during the winter. And then during the summer times, it doesn't really cost anything because we just take all the heating off because the greenhouse itself gets really hot.
Huh. Thank you.
Yeah. Yeah, okay, so moving forward, so this work that I had done for undergrad led me here to to KU and the work that I want to do in terms of just addressing water sanitation hygiene in Alaska Native villages. If any of you are interested in knowing more about that, we could have a separate discussion, but moving forward, so there is a model, it's called the Anaerobic Digestion Model 1. It's a unified mass balance model, so it's based off of like a COD basis, chemical oxygen demand. What it does is it separates the stoichiometry, so what's being produced and consumed, and then also kinetics, like how fast those are being produced and consumed. It has state variables, it has solubles, and then it has your particulates. So solubles are going to be like your sugars, amino acids, your long chain fatty acids, and then your volatile fatty acids as well. And then particulates are just going to be your composites, your inerts, your carbohydrates, proteins, your lipids. And the process that it goes, like what it's based off is, flow of carbon, right? And so first you're going to be starting off with disintegration, you go to hydrolysis, acetogenesis, beta oxidation, and then methanogenesis. And then another component to the whole model is the acid base and pH and gas transfer. So this is really just determines how the model stays physical. So when we're talking about the model, we're really thinking of like physical, biochemical, and physical, principle, and chemical aspects. Also, that book that I had just shared, it is a book that you can buy offline. It's the manual for the anaerobic digestion model. So ADM1 is based off of this matrix. It's called the Peterson matrix. It can get really complicated really fast, and I'll kind of walk you guys through an example after this slide. But basically, the columns, they're going to represent like the components. The rows are going to represent the processes. So disintegration, hydrolysis. And then it's based off of COD, carbon, and nitrogen. Everything else has to equal out to 0. So whatever you're putting in, it has to equal out to 0. And then you have your gas transfer and acid base. So the gas transfer and the acid base equations, those aren't included in the matrix because, the rates are per liquid volume, and those equations are just handled outside of the matrix. And so the process rate column on the very right-hand side is just your monod kinetics for uptake, and then first order for hydrolysis with inhibition terms that are applied as needed. So those inhibition terms are going to be like your specific limits, your upper and lower limit on hydrolysis, your upper and lower limit for pH on acetogenesis, acidogenesis, and methanogenesis. They all have different pH limits, so you need to put inhibition terms on them, just so when the model is running, it knows when to stop that process. All right, this is going to be very generalized, but I'm just hoping to kind of give you an idea of how that matrix that I just showed you works. So I'm just going to show how 1 gram of COD of sugars is split into products and biomass in the process flow. So you have like product fractions. We're going to start with this up here. This uptake of sugar, so process 5. Kind of hard to see the equations in it, but I'll just walk you through it. So there are defaults within that manual that I had just shown you guys that are suggested to use, but with different wastes, of course, you'll have to definitely change them. But overall, you should be able to stay like within range of those defaults. So you take those defaults for your fractions, and then you account for your biomass yield of sugar fermenters. So the biomass yield for sugar fermenters within the ADM1 is going to be 0.10. And that's a gram of COD per sugar, like gram of COD per particulate sugar per gram of COD of soluble sugar. So that leaves like 1 minus 0, 1 minus 0.10, which is going to give you 0.90 of the substrate. So after that, after you have your fractions and then you have your yield, you are going to compute your stoichiometric coefficient. And so what is consumed and what is produced. So you multiply your fractions by that 0.90 that we had gotten from our yield, and you're gonna get individual VFAs that are produced. Individual VFAs that are produced. So QSBU is butyrate, PRO is propionate, then we go to acetate, and then we go to hydrogen. And these bolded letters are what's being produced. And then you have your biomass. So at the very bottom, when you're like putting it all together, you're doing your -1 plus all of your produced products, and it should equal out to 0. And this is just one process. So this is just going to be our row 5 up here in the ADM1 matrix. This is just for one process. So as you go down the matrix, it does get a bit more complicated, but once you understand like one row and how the matrix breaks down, it's pretty easy to understand everything going forward. Yeah, that's all I have for matrix for the model. I can show you guys. Okay. So this is the model that I'm currently working on. What I'm doing is I'm taking the basic model that I received from our collaborators, and I found a continuous stir reactor. Specifically, I'm looking into food waste right now. I am taking this secondary data from these articles, and then I am trying to match the model to the secondary data. So there is a lot going on right here, but I'll just kind of, again, just walk you through. This right here is where I'm building my influence. And so what I'm doing is I am taking that secondary data from that article, and I am doing the calculations first by hand, and then I am placing them within the model just to confirm that everything works out. And then for that, you have to set like your pH. So a lot of data, they have their pH set to a certain number. So for this one, it's going to be 5.8. If you are modeling the anaerobic digestion, it's what you're going to have to do to really try to keep the pH within that bound of 5.8 is you'll have to add acid and bases, which is just like think of it as adding like plus and minus into your charge balances, just so that the system stays at 5.8. This is me clamping it together. So right here is these pH inhibition terms that I was talking about. Each stage of anaerobic digestion has pH limits, and so you're going to want to be aware of that for whatever system that you're trying to reiterate or recreate. Then at the beginning for a CSTR, you have your initial reported value. So this is basically what we're going to be calling our seedling, our seed. You have the digester initial, that's your seed, and then you have your influent composition. And so that's what you're going to be putting into the digester itself. And then right here is where we kind of get into that matrix that I was showing you guys. All of these F's are the fractions of proteins, carbohydrates, lipids based off of the COD. And then we have, the carbon fractions of each process, and then the fractions, and then we have the yields of each process. And then after we identify just like the biochemical processes, the stoichiometric processes, and then the physical processes, now that's where all of the equations come in to, modeling the anaerobic digester. And so, yeah, it does get very complicated pretty quick, but I've had some pretty good success with matching so far 4 secondary data sets with the model. 3 of them are batch reactors, and then that was my first CSTR. So I'm hoping to move forward with getting more CSTR data matched to the model. Any questions? I know that was a lot. And if you have any questions, feel free to even reach out, email. But go ahead, Alex.
Yeah, so when you got some kind of a waste and you're disaggregating it into all of its components and then running each component, row by row in the matrix kind of thing. And I guess I'm just really looking forward to finding out how well does that work, because I keep thinking, oh, what about all the magic synergistic reactions, or interactions that might be taking place. I mean, biology seems incredibly complicated for a mechanical engineering person. So I'm just wondering, do you have a lot of confidence, or are you trying to that this splitting it up into different things is going to work, and or is that the sort of the point of this research, is to bench test this model?
Yeah, actually, it's exactly the point of this research is to see if this model does a good at characterizing the outputs. And so you're asking like, okay, how do I know for sure this is valid? Well, I mean, you can do like R-squared values. There are like statistics that you can do to basically confirm that you are like it's a good fit, right? And so I am doing those processes now. It takes a lot of assumptions, a lot of assumptions to match the data. So just to do my 4 studies, if I'm being honest with you, it's taken me 8 months just to like really understand how to take that data, put it into the model, and then get something that's representative of what they're actually doing. But I can tell you with confidence that it does really well. It does really well.
So far, so good. That's great news.
Jasmine, quick question on when you say it's taken you 8 months to do 4 studies, but that's having to do with like understanding the model and interpreting and fine-tuning your inputs. In terms of computational complexity, how long is a model run?
20 minutes, if that. And that depends on, like how long are you running it? So the studies that I've been doing, the longest one would be 30 days. But and when I say 20 minutes, that includes like debugging. So and that doesn't take long. So once you understand it and you get it down, it doesn't take long at all. And so all you have to do is really create your methodology first, and then apply that methodology to every single study. So right now, even though, yeah, it has taken me time to understand the model, but now I'm at this point where I can spend a full day of looking at data and then matching it to the model. And by the end of the day, I'll have a fit model.
Cool, thank you. And I guess you have the option. So each of these model runs is a simulation of like what would happen under these conditions. And so is 30 days like a reasonable window? What if you wanted to see some trajectory over a certain number of years? Like the question of when do we have too many solids? So in your HomeBiogas example, at some point you'll have maybe too many solids and you'll have to clear it all out. Is that something you could simulate, or you'll probably want to, or can you estimate like at what time would that happen?
Yeah, you can. So like overloading rates, you can model pretty much anything. And there is a lot of research and articles that have already been produced on all these questions that we have already been streamlined. So what was did I answer your question? I'm just so excited about the model. Yeah, I don't remember the end of that question. Sorry, to have to repeat it.
No, I think you got it. It was about capability and timeline.
Oh yeah. You can do it for years. Yeah. So the model that I received from the collaborators, it originally ran for 200 days. So the time is not a constraint. There really are. The only constraint that you'll end up running into is if your COD doesn't equal out to 0, because then that's an issue. Like fundamentally, then your model is just not right.
Well, I think our meeting goes for theoretically another 15 minutes. Is that right? I've got a couple quick things. Let's do a little housekeeping here. Jasmine, first of all, totally cool. Would love to hear from you again at whatever you think is the next juncture of this work. And I hope that other people will check it out, check out the recording. Secondly, Margaret, you put something in the chat which seems kind of important here. Do you want to say something about that? Do you need any help? Which Tom? Who's Tom? And then after that, I'd like to give, if time allowing, our dawdling latecomers, Nate and Sean, a chance to give us a quick update. So anyhow, Margaret, does that sound okay? I'd like to see what you're
Sure, yeah.
posting here.
So Robin Schmidt, who was here and then left and has been a great person for connecting this group to others and is based in Glasgow, UK. He and Every Broadstead, one of the co-founders, and Tom Curtis, who's based in Newcastle in the UK, are enthusiastic about having this group have a session at this event. And all three of them are the sort of people who will definitely be looking for funding for people to attend. Obviously, it's not cheap to get from Colombia to Scotland. But they've been sort of bouncing ideas around on what that event would be. And I just wanted to let people know that, you know, if that is of interest, and this group can help you figure out how to get funding to attend, it could be a fun experience. So I just wanted to sort of have that out there. It's more than a year in advance, so perhaps that can happen. And as you can see, they're trying to build in already people in this group into that agenda. So that's what that is.
Yeah, we all might have more to say, you know, and actually in 6 months or whatever, there's, you know, things are happening all the time as I glean from our updates. So, you know, that presentations could be very different than what you're saying, but the point is we're all doing stuff and this is already more than a year away. So that's pretty interesting. Thank you. I'm going to put this on my calendar as if I would ever have the opportunity to go to Glasgow in October, but who knows? Oh, and of course, we all should know the demonym for people from Glasgow. Glaswegian. If you're from Glasgow, you're a Glaswegian. Okay, onward. There's a fact. Angie's laughing. That's good. So could we hear maybe from who? Sean, then Nate. Is that okay, sure, everybody?
Sorry, thanks for allowing me to join late. We've had internet issues all morning. Oh. Classic excuse, but so kind of update on where we are. We received technical assistance from NREL, and he's kind of been looped in on that. We paused trying to figure out what has previously been done in the region and waiting for a study to be complete from the Department of Transportation on potential feedstocks. So we did find out that NREL provided 40 hours of technical assistance to the community of Unalaska before and suggested anaerobic digestion is the best pathway forward to handle their municipal solid waste and wastewater. Then I just received the reports from the Department of Transportation on fish feedstock. However, their focus was around just fish oil, looking at pursuing like the HEFA pathway to get to sustainable aviation fuel. What I did find though was it did talk about the volumes and potential volumes in the region, so that's a good number to have. So I actually have a draft written for Annie and Anelia from NREL to figure out what our next steps are to get what makes the most sense for the 40 hours of technical assistance. So once that's complete, then hopefully I'll be in a good spot to put in the grant request to the Vehicle Technology Office, which should open, assuming no other changes, in January. If not, then if that doesn't exist, then maybe pursue some public-private partnerships with some of the fishing processors out there who are interested in a renewable diesel with anaerobic digestion as the intermediary. So yeah, that's kind of my big update. Also, if you know anybody in Alaska who wants to work here, we are hiring because for like 4 positions on my team. So I'm kind of trying to just keep it going until we can get fully staffed.
If you want to put a link in the thing with Jake to hiring, that'd be fine. I don't think I need to go up there again, but who knows? I might know somebody. And I do know a guy that's very big on energy stuff there that I used to work with in Brian Hirsch. Maybe you know Brian.
I do, yeah. Brian Deerstone, he owns Deerstone now, and that's one of my contractors. So yeah, I'm very familiar with Brian.
Yep. Okay. And does this connect? Sorry, Sean. Does this connect to Margaret's chiller thing? Is that a possible application for technical assistance or not? Or do you know what it looks like you don't know what I'm talking about. Anyhow, just wanted to, like, that's another possible use for this energy, right? You've got renewable diesel, sustainable aviation fuel, but maybe there's a pathway for chilling at these fish facilities. I don't know.
The 411 on that really quickly, Sean, is that it is a separate add-on to the field experiment in Fairbanks that is using the digester gas as an input fuel source to run seasonal chillers for community food storage. So that's the concept.
Thanks.
I guess all that to say is, my goal is to get to the anaerobic digestion. And if we can pursue renewable diesel, great. But there is obviously a use for biogas, whether that's a chiller or, heating in more remote communities or just residential stoves. So that way I'm keeping in my like wheelhouse of energy related stuff.
All right, Nate.
Yeah, Sean has a lot more interesting stuff to talk about than me. I am up to speed at my job now, so I was in a meeting earlier and I popped in when I could. Thanks so much, Jasmine. I'm always really interested in what you're doing. And I also, just going back to what we were just talking about with Sean, I really like the idea of the biogas for water heating for washerias. And because that's like seasonally, like when people are doing their fish hauls and things like that, it's really good to be able to do laundry. But anyway, let's do our pilot study and have some data to even get the biogas moving forward before we're designing the ancillary systems. In terms of biogas hobby stuff, I am working on getting the Mount Everest Biogas Project's website back online. That is not a thing I can do, and I'm herding the cats and asking the volunteers to please stop traveling to Latin America and fix my website as soon as they have space for it. So that's a really non-glamorous update. And also I may not be visiting Fairbanks this summer. But that might happen in like October or something instead. But sorry, pretty brief update from me on this end. But also, yeah, Glasgow in 2026. Who knows, maybe. I that would be amazing. I would love to go and just attend the conference and show up and represent for the C/HAD group, because I really dislike Chad as an acronym. But yeah. Anyhow, that's all I got, folks.
Thanks. I'm just putting a note in the chat about boilers. I'm sort of looking for a boiler, so this is a little bit self-serving. But for the sheep dairy that I mentioned, their big problem is not just that they have a lot of manure that they don't have a home for, but also that they're suffering from demand charges for running heating equipment. And so heating, using that biogas off of that potential digester for a heating load. So I wondered if anybody knew about biogas, regular readily available biogas boilers. For potentially for raw gas. Like, I don't even know if we're going to clean this gas. I assume maybe we take out the hydrogen sulfide, but maybe not. I don't know. I just anybody that knows about boilers, let's do this. Let's just put it on the. I'll do a little research, and if I learn anything, I'll put it on the agenda. What else for the agenda next time? We'll have Jaime Herrero, Marchi Herrero, and is there something that we went over today that we would? I mean, I see a couple things we could always use updates from people, but anything else came up this that we'd like to put a pin in for a future agenda? I guess the IR pick thing, we'll have to do that next time. I'd like to get started on that. Those IR pick questions. Anything else for the next agenda?
I want to try and give a look at because our NATO funding finally came through.
Yes.
And I'd really like to look at that and like if there are any further gaps in funding to run the NREL pilot next summer and basically look into what further needs to be done for that.
Got it.
Thanks, Nate. I did talk with Jane, it's kind of recently, but I need to follow up with her about that as well. I was going to suggest also, Alex, maybe next meeting I could have more time on the agenda because I'll have updated our temperature plots. We looked at them pretty briefly today. And so we could definitely, if you're looking for things on the agenda, we could definitely spend more time staring at numbers together.
Yeah,
That
that'd be
sounds fun.
cool. I don't see any reason why not. I mean, it's going to be a pretty full meeting. If Jaime takes a half an hour and you take a half an hour, that'd be great. Like we'd have a full hour and a half meeting with introductions and questions and whatever else. So yeah, let's do it. If you could bring that stuff to us, that's awesome. I'd love it. I will have to talk with my co-organizers, of course. Okay. Okay, and then I see Angie put in here sensible seed, a couple actual VNP, very interesting. Fatty fish. But okay. Sounds like Angie's got a wing it model.
That's helpful, Angie.
Okay.
Thanks.
Yeah. Interesting.
Yeah, like I said, I'm not a lab person, but normally that's what we'll try and do. And it's kind of it can be a bit tricky, but if you try different ratios, and the actual little BMP things, I think I dropped in at one stage some quite relatively cheap BMP type sets.
Yeah. I have a very long document of notes from all these meetings, so it's probably in there somewhere.
If not, just ask me and I can try and find some.
So you're talking about like a lab scale stirred reactor kind of thing?
Yeah, lab scale stirred reactors. My ex-boss does some, and sometimes we can convince him to do extra cheap prices for good causes. But yeah.
To run the test or for the equipment?
For the equipment, but most labs, if you have, it just depends because in the UK we never used to have good labs, and we used to have to send everything to Germany, and now we've got some good labs to characterize feedstocks and to do feedstock mixes. But it's also really worthwhile, kind of, particularly if you think you're going to throw different things, it's really worthwhile having somebody who can do that kind of stuff. It's not a money-making exercise by any means, but it's the knowledge is invaluable.
And also on scrubbing the biogas, which Alex, you brought up before, I've seen things where there's just like kind of water trap because you want to get the water out and maybe CO2. Sometimes I've seen people seeding it with calcium and calcium carbonate, and you can kind of get that out. And I've seen different things for trying to get the hydrogen sulfide out. Dr. Hamey, they were just using diapers, the silica in diapers, and that might also help with the other like personal care product stuff that might gum up your thing. But I think hydrogen sulfide's your biggest risk really with raw biogas to just chew up your metal bits on whatever burner. But
yeah,
Angie probably knows more about actual home biogas stuff.
Yeah, we tried some Puxin stuff. We built stainless steel ones, and we didn't take out any hydrogen sulfide, but we did sometimes just have the great blue barrel, where we push the gas through the blue barrel with some activated carbon in the blue barrel, because it's a little bit safer than using bits of metal, because bits of metal can oxidize and go on fire if you're trying to remove hydrogen sulfide. But I've always wanted to try it with biochar.
Me too.
Nancy,
Me too.
we were,
Yep.
so because biochar, we can't activate it enough. Biochar, it would make a really good, I think, hydrogen's, not as good as activated charcoal, but then you could reuse it with the sulfur on the land again. So I think it'd be a great fun thing to try. But
Okay,
your Puxin boilers were best.
I'll check them out. Yep. Thanks, everyone. Really great. And next month we'll have a even super duper better, more. Biogas is everything.
Yeah.
What was the question? Biogas is the answer. Okay.
All right. Great to see you all.
Yeah.
All right.
Take care, everybody.
Love to come to these meetings. Ciao.
Me too. Ciao.
See you later.
Ciao.